Welcome to another tutorial of Proflan YouTube channel. In this video, we're going to have a discussion of IGCSE Physics Electrical Quantities. This is section 4.2 of IGCSE 0625 syllabus. We are going to look at the concept that you must know as far as electrical quantity is concerned. So the first part that you're going to learn is about electric charge. So you need to understand that there are two types of charges, which are positive and negative charges. So here, you need also to understand the law of electrostatics that states that unlike charges attract and like charges repel. Now, for instance, when you have a positive and a positive charge, you are going to expect repulsion to take place because these two charges are like charges, so we expect repulsion to take place. And then we have a positive and a negative charge, we expect attraction. So you need to understand, anytime you see two charges attracting, it means they are unlike charges. One is positive and the other is negative. You need to understand the unit for measuring charge is coulombs. The unit for measuring charge is basically coulombs, and charge is transferred by friction. So you may be asked, how are materials charged? You need to say that the materials are charged when they are rubbed against other materials, and in that way, due to friction, electrons are transferred, and those materials which receive electrons where electrons are transferred to, that material becomes negatively charged, and where electrons are being removed from remain positively charged. So you need to understand that. Now, for instance, if I take a plastic and a piece of cloth, if I wrap these two like that, electrons will be transferred due to friction, and then for that reason, once electrons have been transferred, it will mean that that material that lost electrons remains positively charged, and that material that received electrons becomes negatively charged. So that need to be well understood. So let's move down and get to see what else do you need to understand. You need to understand how to draw electric fields, and you need to know what do we mean by electric field. Now, in this case, you need to understand that electric field is a region of space where an electric charge can experience a force. And usually the direction of the fields point from the positive charge to the negative charge. So if you have a positive charge, the direction of the field will be pointing outwards, yeah, because this arrow here indicates the direction a positive test charge will move if it's brought close to this charge. So which means, since this charge is positively charged, then if you bring a positive test charge close to this positive charge that we are having here, it will be repelled. It will be moving in that direction, and that is exactly what this direction indicates. So in the exam setup, in the event you are told to indicate direction of fields, you need to have in mind that the direction should be for positive outward, but for electrons, for negative charges. For instance, if you are having a negative charge here and you are told to draw electric field patterns, you'll have to draw those direction arrow facing to the negative charge. And why is that so? It's because if you bring a positive test charge close to this negatively charged particle, it will be attracted because it's positively charged. So you'll have to remember that always. Next concept that we are going to look at is the direction of currents. We are going to talk about current electricity. First, current is a flow of charge. When charges are moving from one point to another, that is what we call current electricity. When current flows, when charges flows in a circuit, we need to understand that result to the flow of current. Now, if we look at this diagram that we are having at this given point, you realize that electrons are going to flow from the negative terminal to the positive terminal, but current is going to flow from the positive to the negative. So from this point here, you can see we are having a diagram well labeled here. We have positive terminal and we have negative terminal. Current is going to flow. Once this switch is closed, current is going to flow in that direction. And current is measured using an ammeter, a device called what? Called an ammeter. An ammeter is used to measure current. So you need to remember that current is measured using an ammeter, and ammeter is always connected in series with other components. Here, whatever we have here is what? We have a battery, we have the wire, and when the circuit is closed, current is going to flow, and then we shall have the value of the current being read by the ammeter, and the bulb is going to light let me just write this properly. Current is the bulb is going to light immediately the switch is closed. In the event you are told to measure, if you are told to measure the amount of voltage across this, you are going to add a voltmeter. If you want to measure the potential difference, you are going to add a voltmeter at that point. A voltmeter is a device that measures voltage, is a device that measures potential difference. And in the event you are asked to define the term the potential difference, you are going to say that potential difference is the amount of work done to move a unit charge across 2 points in a circuit. But if you are asked to define what we mean by the term EMF, you are going to say is the amount of work done to move a unit charge across the complete circuit. So you need to understand the difference between the two, that PD is work done to move a unit charge between 2 points in a circuit, i.e. between the 2 points that we are having here. So if this is point X and this is point Y, so this will measure the potential difference. The voltmeter will measure the potential difference, PD, because you are measuring the voltage drop between 2 points in a circuit. But if we close the circuit and we want to know the amount of work done to move a unit charge across the entire circuit, that is what we call the PD, the EMF rather, the EMF. Now, for a circuit to work, we must have an electromotive force, that is the EMF. Remember, the energy is supplied by the battery, and the battery is the one that supplies what we call the electromotive force in this case. So that's why we are saying work done to move a unit charge across the entire circuit is what we call the EMF. EMF is the work done to move a unit charge across the entire circuit. But potential difference is the work done to move a unit charge between 2 points in a circuit. So when we are talking about EMF or the energy supplied, we can use this particular formula that we are having at this given point. And potential difference, we have said, is the work done to move a unit charge between 2 points in a circuit. And if you are measuring that, you use a voltmeter which is connected parallel to the circuit. A voltmeter is always connected what? Parallel to the circuit. And you can be able to see that there are differences between EMF and potential difference. The difference is one is for work done in a complete circuit, to move a unit charge in a complete circuit. The other one, that is PD, between 2 points in circuit. But if you are asked similarities between EMF and the potential difference, you will say both of them is work done per unit charge. And also another similarity is that both of them are measured using a voltmeter, and both of them are measured in volts. Yeah, so the next bit we're going to talk about, the next bit that we're gonna talk about here is the concept of electrical resistance. And electrical resistance is opposition of the flow of current. When current flows through wires, when current is flowing through a device, when current is flowing through a conductor, remember there could be resistance for that. There could be opposition. So resistance in electricity is the opposition to the flow of current, and in this case resistance R is equals to V over I, that is voltage over current. And in that regard, the SI unit, or the unit of measurement of resistance, is given in ohms, which means that you also need to understand factors that affect resistance. And in this case, one of the factors that affect resistance is the length. The longer the length, the higher the resistance. So you can see here this wire is longer, so it has higher resistance. Because we also have the aspect of area. The larger the area, the less the resistance. Because if the cross-section area is large, it means that it's going to, there are more free electrons which can be able to be used for electrical transmission. So thinner wires are susceptible for higher resistance. Next concept that you need to understand is the concept of characteristic graphs. And in this case, under characteristics graphs, you are supposed to understand different shapes. Now, for a fixed resistor, it means it has fixed value of resistance. So which means if you draw its graph, is a straight line graph. But if you have a graph that looks like this, like an S like this, this is a filament. This is a filament lamp. It shows this kind of graph. And this because as temperature increases, resistance of this filament lamp also increases, because due to increase in vibration, and that's going to reduce the flow, the speed at which electrons or electron charge carriers electrons flow. Then we have the characteristics of a diode. A diode is a device that allows current to flow only in one direction. So if you see a graph that looks like this, this represents a diode. A diode is a device that allows current to flow only in one direction. And then if you want to understand Ohm's law, you want to understand this aspect, the experiment that can be able to be carried out to determine resistance is an experiment that has an ammeter. It has a variable resistor. This is what we call a variable resistor at this point. So in this particular circuit that we have here, we have an ammeter, variable resistor. Maybe we have a fixed resistor. We have another ammeter here. And then we have the source of potential difference. So if you collect data from here, remember a variable resistor is used to vary the amount of current in the circuit, and this voltmeter is used to measure the potential difference across this fixed resistor. So you also need to understand the concept of electrical power, and whereby you can see here power is obtained. Power is the rate at which energy is transferred. And but in electricity, power is current times voltage. And then we can also understand that energy can be given as current times voltage times time. But you have to remember that time must be given in seconds. Time should be in seconds, so that in the event that you are asked to work out question and the power is given in kilowatts, you have to multiply that to watts by multiplying it by 1,000. But if time is given in seconds, you have minutes, you have to convert to seconds for you to work it out. All right, so ideally this is all that I wanted us to talk about in this particular tutorial. If you have gotten value from Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. If you are new here, consider sharing and also subscribing to Proflan YouTube channel. See you guys. See you in the next tutorial.